Hello, boys and girls. This is 4th grade Excel lesson 108. This lesson's going to be a little different today. You're just going to have to pay real close attention. So make sure you have no distractions around you, and that if you miss something, you back up and you watch that part of the video again. Super important that you pay close attention today. So what are we going to be doing today? We're going to be learning the distributive property of multiplication. That's what we're going to do first, these red dots that you see up at the top. We're going to learn that distributive property up there. And then we're going to learn another property called the associative property, and that is going to apply to multiplication and addition. But first, the distributive property of multiplication. So here we go. I've built an array out of red dots. It's not real well organized, but I did my best there. And on this array, we have 3 levels, and each level has 6 dots on it, right? So what we have here is 3 times 6. Now, what I'm going to do to demonstrate the distributive property, I'm going to split this array up into 2 parts. On the left side over here, I instead of 6, now I have 4. In fact, let me erase that. I'm going to erase that up there. Gone. Okay. Now, I've got 4 going across the top and 3 down still. And then over here, I have 2 going across the top and 3 down. So I'm going to say right here, I have 3 times 4. And over here, I have 3 times 2. Now, there's another way that I can write this. What I really did was I split the 6 up into 2 different numbers, 4 and 2. 4 and 2 make 6. And then I'm multiplying all of that by 3. 3 times 4 plus 2, right? And does that come out the same thing as 3 times 6? Well, 4 plus 2 is 6. So 3 times 6 is 18. There's still 18 dots. And this is the same thing as what we see here plus what we see here. We're putting this part together with that part. So what I have is 3 times 4, and I'm adding that to 3 times 2. Just like that. All right. And that shows the distributive property of multiplication. I'm multiplying 3 times 4 and adding that to 3 times 2. It's like I'm distributing or passing out the number 3 as I multiply it with the 4, and then I multiply it with the 2. And that's what you see right here. Let's take a look at another one, shall we? Let me erase that. And, oh good, I kept the red dots there. That's kind of cool. All right. There we go. Let's do another one with these same dots. Back to here. Okay, what if I split this right here? On this first part, I have 1. The next part, I have 5. I still have 3. So I have 6 times 3 still, or 3 times 6. And the 2 different parts that make this up are, I'm taking the 6 and making it into 1 plus 5. So I have 3 times 1 plus, 5. And that's the same thing as doing this part, which is 3 times 1, and adding this other part over here, which is 5 times 1. That's the distributive property. So now we're going to move down to here and take a look at the examples that they're giving us, all right? Here we go. So the distributive property of multiplication means that you can multiply a sum or a difference by multiplying the parts and then add or subtracting the results. So this problem here, 3 times 2 plus 1, is the same thing as saying 3 times 2 plus 3 times 1. Do you see where they got the numbers? Right there. So let's take a look at what this would look like if we have, oh, somebody's calling me. I'm just going to ignore that for right now. Let's say we've got 1, 2, 3, and then 3, and then 3. I'm splitting these 3 up into 2 plus 1. So I've got 1 here and 2 there, and all of it's getting multiplied by 3, right? So 3 times 2, which is that part right there, and 3 times 1, which is that part right there. Okay, and 3 times 2 plus 1 is equal to 9, because 2 plus 1 is 3. 3 times 3 is 9. 3 times 2, this part right here, is 6. And 3 times 1 is 3. When we add 6 and 3, we get 9. Comes out the same, see, no matter which way I do it. Let's take a look at it. Another example. 4 times 7 minus 2 is the same thing as doing 4 times 7 minus, because it's subtraction here, 4 times 2. Let's prove that. If we do this first one right here, it looks like this. 4 times 7 minus 2. 7 minus 2 is 5. 4 times 5 is 20. This comes out to be 20. 4 times 7, this one right here, is 28. And 4 times 2 is 8. Right, that part right there, I'm doing right here. And 20 minus 8 is 20. It works perfectly. This can be helpful by calculating products mentally. 5 times 97 can be written as 5 times 100 minus 3. Instead of thinking of this as 97, I can think of 97 as being 100, take away 3. Well, 5 times 100 is 500, and 5 times 3 is 15. So 100 take away 15 is 485. So you can do 5 times 97 in your head by using that little trick there. All right, the next part, the associative property of multiplication, means that changing the grouping of the factors will not change the product. What that means is you can group things however you want in a multiplication problem, and the answer is going to be the same. 3 times 2 times 4, if I do 2 times 4 first, or if I do the 3 times 2 first, I'm still going to get the same answer. Let's prove that. 3 times 2 times 4, well, if I do this first, I get 8. Right? And 3 times 8 is 24. The order that you do things in multiplication doesn't matter. You can do this part first. Or 3 times 2 I can do first and get 6. 6 times 4 is 24. Now, to show me that you're paying attention right now and that you haven't stopped watching the video, right down here where I just drew that little slash, I would like you to draw a picture of a flower. Draw a picture of a flower on your paper right where I drew that, and that'll show me that you're paying attention. When I check your paper tomorrow or today, I'm going to check to make sure you have a flower right there, and that means you really paid close attention to the video. Okay, the next part says this can be helpful in calculating products mentally. And by the way, don't tell anybody about the flower. It's a secret. Shh, big secret. Okay, you can't help anybody else out on that. Otherwise, you're going to be robbing them of their learning, because that means that they're not paying attention to the video, and yet they still get credit for watching the video. That would not be good for them. This can be helpful in calculating products mentally. So another way of doing this, 2 times 5 times 3 can be written as 2 times 5 times 3. Well, 5 times 3 is 15. 15 times 2 is a little bit harder than doing 2 times 5 first, which is 10. 10 times 3 is 30. Well, 15 times 2 is also 30, but it's a little bit simpler to do the 2 times 5 first. So the order that you do things in multiplication problems can actually make it easier, but you'll still get the same answer. This same property works with addition. Let's take the problem. Let me write this here so you can see what we're talking about. That might help you. 7 plus 2 plus 4. Does it matter if I add this first or this first? Does not matter one bit. We get the same answer. So if I do 7 plus 2 plus 4, or 7 plus 2 first, and then add the 4, I still get the same answer. This one I'm going to do right here. I'm going to add the 2 plus 4 first, which is 6. 7 plus 6 is 13. Or if I add the 7 plus 2 first, I get 9. And 9 plus 4 is 13. Does not matter. See, the 13 and the 13 does not matter which one I do first. If I add the 7 plus 2 first, or if I add the 2 plus 4 first. Same thing. Whoa! Forget that. Okay, same thing up here. what we just saw was that 3 times 2 times 4, it doesn't matter if I multiply that first or if I multiply that first. Okay, this also can be helpful when calculating sums mentally in your mind. 7 plus 3 plus 28, well, this is a little tricky, 3 plus 28, but if I do the 7 plus 3 first, that's 10. 10 plus 28 is 38. Easy to do in your head. All right, hopefully you understood all that, and do the division facts now. Pause the video, turn it back on when you're done. So you should have already done this. 12 times 6 is 72. 3 times 8 is 24. 7 times 4 is 28. 8 times 6 is 48. 4 times 9 is 36. 8 times 4 is 32. 9 times 8 is 72. 6 times 5 is 30. Next row. 11 times 2 is 22. 7 times 6 is 42. 6 times 9 is 54. 3 times 9 is 27. 12 times 8 is... I had to think about that one. 7 times 7 is 49. 6 times 6 is 36. 7 times 8 is 56. Thank you so much for watching.